Good morning. Well, I guess it's not necessarily good morning for you, but it's good morning for me right now. This is 8.1.2 day one, and we're going to work on choosing the mean or median. And as we work through this, the very last question is kind of the critical question to today's lesson. So if you leave here understanding that very last question and can leave here remembering that question, then that means that you've kind of got the main point about today. So we are, just as a quick review of mean and median, why don't we just head down to the measures of central tendency. Now this is at the very end, and so these talk about the center kind of data, and the mean is what we call the arithmetic average of the data set, and that's right here. One way to compute that mean is to add all of those things up and then divide by the number of items. So for example, we had down at the very bottom here under these examples, we see the number of home runs hit, right? Here are all the home runs, and then how many teams did that? 1, 2, 3, 4, 5, 6, 7 of them. So we add up all those home runs, share it, I would guess you could say, divide it by 7 to find that the average or the mean was 15.57. Now, think about this again like our families problem in 811. I know that this seems a little odd, but if there were 16 family members, 16 family members in one family, 26 in another, 21 in another, 9, 13, 15, and 9, and we share those blocks amongst everybody, and we could cut blocks in half, then we'd have 15.57 blocks for everybody. Okay. The median is the middle number. It's not just that middle number, because here's the other part about it. It's a middle number that is in order. All right, and then it says if there's an even number of values, the median is the average of those two middle ones. Right, so the median is more accurate than the mean when, well, here it is. This is really the big part or whatever, when there are outliers. That's the big thing. That's when medians are much better than means. So down below, they took all those numbers and they did exactly what they said. They arranged them numerically. They put them in order, and then they go to find that middle number. Now, when I go to find that middle number, I think it's nice just to kind of cross off and work your way to the middle, right? 15. There it is. The median's 15. If I had two different numbers there, right, I get to the middle and there's 2 left, then I have to find the average of those, find the middle of those two, okay? So let's start over here and let's get this moving. So we're going to go back to Calaveras County for that frog jumping contest. There's the 2008 and 2009 frog jumping information. So we are going to really kind of use this throughout most of the whole lesson. Just take a look at that data real quick in 2008 and 2009, and do you really recognize anything, or does anything stand out to you? Looks like 2009 might be a little bit better, 252, better number. They have a little bit better stuff there, it looks like. Well, let's find out. So your first job is to make a graphical representation of the data. Why would we do that? It's so much easier to understand and to see data if we're looking at that, okay? So what we're going to do is, so we're going to make that graphical representation. How does this representation help you analyze? Well, we'll see in a moment. And so we're not going to use the Student E tool. If you do on the CPM book, you can use that Student E tool. And then just take a screenshot, and then that could be part of your upload. But if you're in this sheet, we'll create it together. And then we're not going to look at one that a teacher displays, but then the very last part says the bin size of each histogram should be 10 inches. That means if you take a look, it goes from 210, right, to 210 to 220. That is an increase of 10. That's a bin size of 10. Why is a histogram a good choice? Well, we're going to see in just a moment. Okay, so if we go up here, what I found is it was a whole lot easier for me to actually break them down into little groups. So I'm going to actually do that now, right? Here's my 230s. And you know what? I'm going to do my 230s over here as the same color. I don't have to. Let's get that 252. It's a color. Sound good there. Now the 220s, let's make them green. Again, you don't have to do colors. I'm just doing colors to help me organize my data, okay? And then on the far left, I've got 217 and 16. We'll make those blue. I can't do the 200 or 185 because it's like a different group, so I'll just make it black, okay? Let's do this, and I'm going to use colors to help me organize this data. So you can see exactly why I created the bins that I did down below for the histograms. So you notice on the left, I had 2 blues in 2008. Those were in the teens. So let's go to those teens and let's make it a bin size of 2, right? There it is. See that? 2 of them in the teens. How many do I have in the 20s? I got 4 of them, and I have 2 of them in the 230s, right? The greens and the reds. So let's fill those in. I had 4 220 values, so let's fill that up to 4. And then in the 230s, I had 2. There we go. And that's my histogram for the 2008. Let's go to the 2009. We're going to use no blues, since we don't have any in the teens, but we do have that 185. So let's put that one in the 180 group. Oops, this is frustrating because they are very jumpy the way they have this stuff on the far right, so I apologize for that. In the greens, we have 4 of those in the 220s, so same as the other one, isn't it? Wow, that's quite a space right there. How many in the reds? 2 of them. 1, 2. And then in the yellow, we had 252, right? Let's go to the 250s, and we just have a 1 right here. There it is. So now we can actually answer that question, right? Why is a histogram a good choice, right? There we go. There we go. Why is a histogram a good choice? Well, I think you can see it now. In the 2008 data, look at how that stays together. It kind of looks like normal data, meaning a few small values on the edges, most of it's in the middle. But if we look at the 2009, we do have a peak, just like 2008. But look at those, that yellow and the black section, right? Look how spread out those are. We have special names for those, and you probably know what that name is, and we're going to get to it in just a second. What was more obvious when you looked at the histograms compared to looking at the list of data? Is there information that's easier to see on the histograms? What was more obvious? I think what was more obvious was just how the data is spread out. It is easy to see how spread out the data was, right, for each year. Is there information that was easier to see on the histograms? You bet. If we take a look at 2009, we have those 2 values that are spread out. Those were easy to find, right? And what do we call those? It was easy to see the outliers, right? Those values that are far away. I'll call that a vocabulary word. Those values that are far away and not like the rest. I feel like is it a Sesame Street song? Which one doesn't belong? The technology tool shows the mean and median of the data below. We don't have that right now. However, if the mean and median were not labeled, would there be a way to determine the median or mean from the histogram alone? So let's just look at that histogram. Is there a way for us to do that? Well, I'm thinking about this, and as I look in 2008 under the green section, right here, do I know what the values are in there without looking up here? The answer is no. So I can't find the mean or the median in each case, right? So would there be a way to determine the mean or median from the histogram? No. We cannot find the mean or median because we do not know all of the values. 8.13, use the list of data, and 8.12 are the histograms to continue to analyze our data. So the range is, I should finish reading the question. What is the range of the jumps in each year? What does this tell you about the frog jumps? Well, let's take a look at the range for everything is the largest take away the smallest. So in 2008, you can go back and find that data. That was 231.5. The smallest value was 216.5 for a range of 15. In 2009, the largest value was 252. The smallest value was 185.25, and that is 66.75. So let's finish answering the question. What does it tell you about the frog jumps? It tells you how spread out that data was. This is really hard for me to write because of that stuff. It shows what data was more spread out and which ones were together more, right? What's the typical jump length of the frogs each year? How did you find this value? So in here, to kind of do a comparison, it's easy for us to find the median and mean. If you did the E tool, you could easily grab this. In here, I'll actually put that in. So the median for 2008, for example, is the middle number. Like we talked about before, the mean is where we add them all up and divide, right? So let's go back up and let's look at the mean for 2008. The median, I mean. Let me use a different color here to kind of keep things mixed up so it's not so hard to tell. So we're going to work our way to the middle, right? The median. They're already in order, which is what we need, right? So done. There. Ooh, I'm left with two numbers. So in order to find the median is the middle of those two numbers. Well, it's really just the average, okay, of those two numbers. So what we do is we do 227 plus 221.5. What we do is we add those numbers up, and then we're just going to divide them by 2. We're finding the average of that. I don't have that total in front of me, and instead of you waiting for me to do a calculation in there, why don't I just tell you that when I add those two up and I divide it by 2, that I get a median of 224.125, okay? So let's jump back down here. And the median turned out to be 224.125. If we did the same thing for 2009, the median should turn out to be 224.25. Just thinking here, those numbers are pretty close despite the crazy looking graph of 2009. Let's talk about the mean then. Well, the mean, I think I messed up. I did. I apologize. I'm reading the wrong numbers for this. That was the mean for that. Let me give you the right numbers, and then let me go up here and fix this. That was not 200. That one was the median for 2008 would have been the 224.25. I apologize. All right, so now let's go back down. Oops, that's too far. The median for 2008 was the 224.25, and the median for 2009 was 225. The mean for the 2008 is where we add up all those numbers, right? And when we add them all up for 2008, we have 100. 1,793, and we divide by the number of numbers, which is 8. When we take 1,793 divided by 8, we get, there's my 224.125. That's where I screwed up and read the wrong number. That looks like a 9, and I want to fix that and make sure that that's read correctly. That is a 4. Hard to write sometimes with this iPad on here. Under the mean for 2009, when you add up all the numbers, you get 1,800.75, and you divide by 8, and that becomes 225.1, approximately. I'm going to put an approximate symbol, 225.1. So, what was a typical jump length for the frogs? Well, actually, you look at it, they're all pretty much the exact same, right? 224, 225. And how did we find that? We found that from the mean and median, right? So, about 225. And I'm running out of space, so I'm just going to say from the mean and median. You can write that in a much better sentence there than I could. Were the jumps all about the same, or were some jumps outliers? Well, we did find that there were some outliers, didn't we? We talked about them in 2009. Name any of those outliers and explain why you think they're outliers. So in 2009, we had two. We had 185.25, and then we had 252 for both of them. If I jump back up and take a look, we can see here's why we think they are. I mean, take a look. There's these big gaps, especially here, right? Big gaps there between the normal values, and even this 185 would be way over here on 2008, and even the 251 would still be way over, right? So we see that these are outliers because they just are not close to the numbers, right? So why both values are far away from the normal jumps. Compare as completely as you can in 2008 jumps to the 2009 jumps. Compare the center, shape, spread, and outliers. Then draw a conclusion where one year's frogs are better group of jumpers than the other. How do you know? The center, if we just look at the picture of the histogram, they're about the same, aren't they? I think they just call them similar. We already wrote the range, so I just kind of kept the range here, but you can see how spread out that 2009 is, right? The shape of them, right? I think you could say that the 2008 stuff was what? Close. They were compact. I can't write very well because I'm running out of room with this stuff, right? They were much more together, where the 2009 was what? More spread out, wouldn't we say? And then the outliers we already had listed in there, right? So then draw a conclusion. Were one year's frogs better than a group or better than another one? I don't know. I mean, this is really up to you. You could say that they were better in 2009 because we had that much larger value. But if you look at the mean and median from up above, right, they're about the same, aren't they? So I would say that they're about the same. You know, that's just my call. You could argue for the other one. So now here's the key part for all of this section is this 814, choosing the mean or median. It's important to look at the distribution of data when deciding whether to use the mean or the median. In 2008, which represents a typical jump better, the mean or the median? Well, in that, I'd say, remember that in 2008, the mean was 224.125, and the median, this is from the previous problem, was 225.125. 224.25. Same, right? I don't really see much of a difference in this case. The mean or the median, they're about the same. If the ninth place jump in 2008 was very small, such as 160, redraw the histogram from problems 812 and include the new jump. Well, let's do that. 160, well, that would put one of them right down here, wouldn't it? I put the other ones up there, but then I would have to go back in now my 210 to 220 range, right? So if I'm looking at this, this blue in my 2008 is one less now because this value right here is no longer 216. They just said, hey, let's pretend it's 160. So if that's 160, I only have one jump in that blue section. And so I need to fix that to be one jump here. Okay, boy, now that's a new, in fact, I could just call it my new 2008 data, right? Okay. Without using the calculator, make a prediction. How does adding this outlier affect the mean and the median, right? Well, the median is still the middle number. That median, right? That's that middle number. Does it really change? Well, the middle number is still the middle number, right? If I've put them in order. So I have no change to the median, right? That would still be the 224.25. So what would be the mean? What would happen to the mean? Well, the mean would definitely have to get smaller, right? I mean, if I took away a value that was right here, right? I took a value here and I put it way over here, right? That would have to make my mean smaller. It would become, whoops, smaller. All right. Now we need to use our calculator to test that actual prediction. If we add up all those numbers again, and then we just divide by the number of values, in this case, we added up all the numbers, we would get 1,953. Whoops, I take that back. No, that would be. And then we divide that by 9. Am I looking at the right problem? I will think so. Redraw the mean is a big change, smaller median makes 1,953. I feel like that's not quite right here. Did I made a mistake? 2009. The mean represents, I don't know if I have that. That doesn't seem right here right now. No, that is not right. I must be looking or made a mistake somewhere in my calculations. We got to add up all those values instead of you listening to me add up all those values and then dividing by the number of values. I know that it will be smaller. I have a miscalculation somewhere. That mean would have become, I think it becomes 217, and you might want to check me on that one. I have the wrong stuff sitting in front of me there. Oh, I know why I messed up. I apologize. I know why my numbers are all screwed up. This isn't right. They said the 9th place jump. All of you have probably been thinking this the whole time. Why is Mr. Krohn doing this, right? The 9th place jump. I didn't replace the 8th place jump, right? The median would get smaller in this one. I'm sorry. The median would get smaller. That's why these numbers are messing with me. But it wouldn't be a lot, would it? Wouldn't be a lot. Small change, because my middle, I'm sorry about that, my middle would go from between these two numbers, right, to actually it would become the 221.25. So it would go from 224.25 to 225. And what I'd have is I'd have my 160, I think it is, right here. So there'd be my 9 numbers. And if I made my way to the middle, it would be 221.5. I'm sorry about that. So I'd have a small change, and it would become 221.25. I'll put that in the next one. And then we knew the mean does become smaller, doesn't it? So we're going to predict that or check that, and this is why stuff was all messed up. So I apologize. Now I know. If I add up all those 9 values, that's where I get 1,953, and we divide by 9, so 1,953 divided by 9, because we have a new number, and that becomes 217. The median, I did just tell you up above, would change to 221.5. So let's compare those to before. All right, let me put that in a different color here, in orange. The mean before was, for 2008, that was 224.125. That was a big drop, wasn't it? And the median before was 224.25. Yep. Yeah, there it is. And that one was a drop too, but not nearly as much. I mean, this was a drop of, the mean was nearly a drop of 7. This was just a drop of about 3, right? Big difference. So looking at the histogram, does the mean or does the median better represent that typical jump? Let's take a look, right? Does 220 or does 221 or does 217 make a better idea? Well, 221.5 would fall somewhere right around here. Then the 217 falls somewhere here. Which one seems like a better pick? Well, I'd say that that median in this case is a better pick. So here it is. When does the median represent a typical jump better than the mean does? This is the critical part to the whole lesson. The median is a better choice. When there are outliers. Outliers. That's usually when it's best. Especially outliers to one, or outliers to like one side, either to the far right or to the far left. So we'll just say especially outliers to one side of our values, right? Or one left or right. All right, we went through this. There's those answers. You can double check that sort of stuff. Or just a reminder in your homework, be sure to show your work. And that's how I know that you did that. Okay, be sure to show your work. If you have any questions, let me know.